So today we are very pleased to have Dr. Jacob Chen to deliver the first talk in the distinguished seminar series of our new department, Department of Advanced Design and Systems Engineering. Dr. Chen is a vice chairman of Honghai Foxconn Technology Group and founding president of Foxconn University, which is the corporate university of Foxconn. Okay, so prior to joining Foxconn, Jacob served as dean of the College of Science and Engineering at the University of Texas, America, and he was also previously with the Department of Industrial Engineering at the University of Houston and served as department chair. So Dr. Chen has published more than 120 reviewed articles and supervised many PhD and master students. And Dr. Chen is a fellow of RSE Institute of Industrial and Systems Engineering, among other awards and recognition. To cut the introduction short, let's just welcome Dr. Chen to deliver his talk. And if you have any questions during this talk, please type it in the chat window, and we will have a question and answer session after that. And during the question and answer session, and you can unmute yourself and ask any questions directly. Okay, so thank you. So please, Jacob.
Good afternoon, ladies and gentlemen. And first of all, I would like to congratulate to the new BE degree program in Intelligent Manufacturing Engineering. And indeed, it is my great pleasure to have this opportunity, sharing with you some of my personal experiences and viewpoints on the Intelligent Manufacturing System, IMS, especially from the people-oriented viewpoint, and of course, share my passion and some of my approach in talent cultivation in IMS. And this topic reminds me of long time ago when I was still at the University of Houston. And I used the same topic, same terms, intelligent manufacturing system, when I taught the course at the UH. Indeed, I consider myself as a very lucky person with opportunity to work both in academic and industry. As shown in the slide, I taught and conduct research in the popular areas 35 years ago and today, such as AI, especially the time we talk about applied artificial intelligence, end up in the natural language processing, in our robotics and expert system. From the two areas, one is from human cognitive modeling. Another one, of course, comes from computer technology. And now we use the same theme, very similar to 35 years ago we used in research and application. Due to the pandemic, most of our schools are offering more courses online. Indeed, during my tenure at the University of Houston, we already offer our courses and degree in IE and engineering management real-time, virtually through our microwave distant education system to our students from a compact, that is HP now, Texas Instrument, TI, Houston Medical Center, and NASA Johnson Space Center and its contractor. For example, Martin and Rockefeller. In late evening on the university affiliate public TV station. To whoever missed the class during the daytime or would like to review it again in the evening. Of course, recorded courses will also be available in the library. With the technology development, now we have a more computing power and faster communication speed and make the online education easier than before. Then, of course, many of you already know the Honghai Foxconn Research Institute signed a MOU with the City University of Hong Kong yesterday. And as stated in the news, in the future, the two parties will focus on AI, semiconductors, information security, 5G, XG, and other new generation communication technologies. And will join hands in forward-looking technology research and development. And President Kuo also said, through industrial development and innovation to promote personal exchanges, we also hope that we can join it, cultivate future technology leaders. And last night, Professor Say told me, and it's fine, kind of, coincident. We have this, MOU signed it. So I would like to propose and consider my talk today will be the first activity after MOU was signed yesterday. Well, I plan to cover the following topics today. Firstly, to begin with my personal view on people-oriented philosophy with a few examples. Secondly, I will discuss the chronicle of the Foxconn business and operation innovation, and also the Foxconn digital transformations. Thirdly, I will brief you two Foxconn Lighthouse Factory awarded by World Economic Forum, WEF. Then present you a new transformation model derived from the Foxconn practices. I call it the double helix transformation model. Of course, I will show you how we cultivate and certify our talents in industrial manufacturing system areas. I show with the Chinese character of people. Then, I believe that the people-oriented should cover three different aspects. Firstly, to respect people and beyond the compliance of law and regulations, professional standards, companies' visions, code of conduct, and expectation of all the shareholders, from employers, stockholders, society, government, NGO, and etc. Secondly, to optimize, augment, and amplify human performance in the work and the life with assistance of new technologies. Thirdly, as listed in the U.S. National Science Foundation Big 10 ideas, future of the work at the human technology frontiers, catalyzing interdisciplinary science and engineering research to understand and build the human technology relationship, design new technology to augment human performance, illuminate the emerging social technological landscape, and foster lifelong and pervasive learning with technology. Through this, I believe, unless we really have people-oriented and integrate humanity and technology, otherwise, some of the we worry nowadays for technology development may happen. Fail to comply with the law and regulations, professional standards, society, code conduct, especially customers' code conduct. The company may lose their opportunities to scale new business. For example, 3 of the Apple EMS suppliers, P company, W company in China, L company in Vietnam, were quote-unquote penalized by losing the new and existing orders, as stated in the news. Another example actually is a successful example from Samsung. Samsung used education-focused strategy to promote corporate social responsibility, CSR. Samsung has transformed its CSR from CSR 1.0, simply compliance, to CSR 2.0 various generations, to CSR 3.0 promoting 3 sets of objectives. First set with initial character of S, social, sharing, and sustainable growth. Second set of objective with initial of character P, people, planet, and profit. And the third set of the initial of the character E, environment, economic. With this three set of the objective, Samsung expanded its business in Africa with the strategy of building in Africa for Africa by Africa. Since the strategy is built in Africa for Africa by Africa, so the training and develop qualified engineering and technicians is the first step to explore their business in Africa. As shown in the pictures in this slide, solar powers mobile classroom and a laboratory providing the student hands-on experience. And a mobile application were also developed and employed with a great success. And of course, in 5 years, it achieved the $10 billion revenue business target and also received a famous branding for Samsung in Africa. So that is a successful story and also bad example in the business aspect if the company without complying the law and regulation, without respect the people. Where industry promoting corporate social responsibility, many universities around the world are also promoting university social responsibility, USR. Leading by the Hong Kong University with other 15 universities worldwide, including Beijing University, Beijing Noble University, Kyoto University, Washington University, established USR network in 2015, bring together a group of the thought leaders to exchange ideas, resources, practice of various scope and scale to steer global discussion and develop of the university social responsibility in higher education. As shown in the CTU University Hong Kong homepage, CTU positions itself as a world-class university, one that provides quality professional education and pursues applicable research in a manner that balances growth with social responsibility and sustainability. I believe that the collaboration and the cooperation of the University Social Responsibility and Corporate Social Responsibility Program is the new model of the university industrial partnership. Indeed, City University of Hong Kong's vision of the USR coincides with Foxconn's sustainable business philosophy. We believe that the sustainability equal EPS and ESG. In Foxconn, we believe in technology is created by people, used by people, and blessed by people. Ms. Kyochino Toyota, the founder of the Toyota, said, "A machine is complete only when it works in perfect harmony with people," as shown in Dr. Jeffrey Liker's famous book entitled The Toyota Way in his 12 principles. Principle A said, technology is pulled by manufacturing, not pushed to manufacturing. Use technology to support people, not to replace people. With productivity and quality improvement, few people may be needed in operation. Instead of let those people go, those employers should be provided with upskill and reskilling opportunity. Please be emphasized that the optimal goal of the AI development is IA, intelligence, argument, and amplifications. And I show this slide to demonstrate another example of the human promotes optimization, augmentation, and amplification. That is Toyota's robot, and they call it partner robot. They use this robot, to the area of rehabilitation, social well-being, and health care areas. Indeed, various types of the exoskeleton have also been applied to support and protect human body in the production floor to reduce the injury rate and the series of the injury, especially on the cumulative musculoskeletal disorders. And the third aspect of the people-oriented, I call it to establish the harmonious human-technology partnership. And it's the number one ideas in the U.S. and National Science Foundation Big 10 ideas. To work on the human technology frontier, shaping the futures. Of course, and fostering the reskilling, upskilling, and lifelong learning is the key of this program. As shown in this slide, 20-some years ago, Dr. Nancy Curry-Great, who was my PhD student, and she is the experienced astronaut, were working with the RobotNaut for space mission. Dr. Nancy Curry-Great had 4 very successful missions during her tenure with NASA. Currently, she is the professor of industrial and system engineering at the Texas A&M University. With the rapid development and the convergence of the exponential technology, such as AI, robots, big data, next-generation communication technologies, quantum computing, cloud computing, etc. So, the fostering, reskilling, upskilling, and the lifelong learning is the must to the futures in the working areas. And Google, Apple, Amazon, Microsoft, and other high-tech leaders are taking leadership in the area of the new model of reskilling and upskilling. And US NSF, they suggest in the futures, more and more industry need to share more responsibility for training. Also to recommend the new industry needed to increase access of the people toward the education and training. And also need to develop new modes of deliveries for training and education. And of course, industry and university have to redefine matching of the workers to skills, and also work together to redefine credits, credentials, and qualifications. So that is why in China, and they have a program called 1+N. One, of course, is university diploma, no matter bachelor degree, master's degree, or PhD degree. And that's me, the different type of the professional skill certifications. And using the Chinese 8 diagrams, or we call the Bagua, I would like to demonstrate what Foxconn are unchanging and what Foxconn are changing. During our short history, 47 years old, that is not too long. We won't change our core corporate value culture. We won't change our core industrial competitiveness. And we won't change the philosophy of focusing on the core business. With dynamic change of the economic environment and rapid innovation of high technologies, we definitely are changing our industrial value chains, workforce structure, and the global operation system. Our founders, Mr. Terry Guo, once said that Foxconn is enforced to innovate under the pressures from outside and inside. Reluctantly inherit during growth and continue to rapid growth with our core competencies in speed, quality, service, cost, and delivery. And he joking, we are so lucky. But unless you have your core competence, even you are lucky, have opportunity coming, you may not have a chance to grasp the opportunity and convert into the business. And I will spend a little bit longer to share with you the chronicle of Foxconn business, operation, and innovation. Personally, I classify the chronicle of Foxconn business, operation, innovation into 9 phases. And I would like to reemphasize, it is only my personal opinion. It is not official chronicle of the Foxconn. From 1974 to 1993, the resources integration phase, Mr. Guo, just like every other entrepreneur, try their best, try very hard to scale resources, including customers, technologies, talent, capital, to survive and grow. From 1994 to 1995, the vertical integration phase, Foxconn focused on core component business and the core technologies. Company also concentrate on filing and protecting patents. From 1996 to 1998, I call it reverse integration phase. Bare-bones systems are key business with 1 site design, 2 sites manufacturing, and 3 sites delivery strategy. From 1999 to 2001, I call it the horizontal integration phase. Foxconn expanded business from bare-bones system to 3C system and evolved strategy to a new component module move service, CMMS model. We manufacture chassis in China and Taiwan and deliver it to the United States and Europe for the last mile assembly to bring our manufacturing and engineering services near to our customer and the markets. ERP system was installed at that time to communicate with our customer in product design and the operation and the services. Indeed, it was the first step and the core foundation of our digital transformation. From 2002 and 2003, the diversity integration phase, a new business model of the joint design manufacturing, we called it JDSM, and joint development manufacturing, we called it JDVM, were innovated leading to the JODM and ODM, and expanding our product lines into the communication and the consumer electronic product. After 2002, all phases are focused on value generation and increation by taking advantage of the Foxconn core competencies in supply chain management and manufacturing technology. A new business model called IDM, Integrate Design Manufacturing. IIDM, Innovative Integrated Design and Manufacturing, and IIDM SM, Innovative Integrated Design Manufacturing, Sales, Service, and Marketing, were innovated and implemented. Indeed, our founder, Mr. Terry Goh, announced the IDM model in the APEC held in Indonesia. Many people still consider Foxconn is the leader in EMS business. However, although we are in the EMS business, we have already transformed from industrial manufacturing to technology manufacturing to a comprehensive technology integration service provider now. Although Foxconn is well known as the king of outsourcing, many of you may also learn the Foxconn from the different resources. It would be a great idea to learn more from our official promotion video to help you having comprehensive understanding of the real Foxconn. It will take about 5 minutes.
We are entering into the smart era. Commerce, industry, and society are rapidly evolving and transforming. We are living in a way our ancestors never could have imagined. We have access to real-time information at any given moment. We are using the most cutting-edge technology products. We are living healthier lives. The ideas in our imagination are slowly becoming reality. 40% of these electronics and technology products come to reality in Foxconn. Since Foxconn's founding in Taiwan in 1974, and initial investment in mainland China in 1988, we've already built over 40 technology parks and R&D centers in mainland China. We have over 800 subsidiaries and stations around the world, including Asia, Europe, America, and Oceania. We're changing the way people communicate and live every day. We make products with displays of all sizes, network transmission and cloud storage technologies, cloud computing, mobile devices, Internet of Things, big data, AI, smart networks, robotics and automation, and new products and services for the industrial internet. Every day we are extracting valuable insights from oceans of data, so we can provide more value for your smart life. Every day, we are constantly trying to perfect our products and pursue the highest level of service, so that our technology can make your life more convenient and happier. The industrial internet platform is the key to the nation's manufacturing industry and establishment, consolidation, and strengthening of its competitive advantage. As the world's leading industrial internet, smart manufacturing, and technology service solution provider, we have already built an industrial internet platform that integrates cloud computing and HPC platforms, HPC data centers, telecom and cloud service equipment, 5G and IoT connectivity solutions, and new R&D applications for smart manufacturing into a vertically integrated industrial internet platform, while simultaneously achieving people-less and fully automated smart manufacturing. We will also empower a large amount of SMBs and help them improve quality, increase efficiency, lower costs, and decrease inventory. While you are enjoying a happy life, we are solving difficult technology problems. We are working hard to create the perfect life. We will make breakthroughs in current technology challenges, whether it's business dealings, virtual commerce, remote education, or healthcare. With revolutionary 8K plus 5G long-distance video conferences, doctors and medical professionals will be able to obtain visual data more quickly and hold long-distance consultations and surgeries. Hospitals in remote areas can hold real-time video conferences with advanced hospitals, preventing the need for patients to make long journeys to seek the care they need. 8K plus 5G will initiate a new type of life for mankind. Every family seeks comfort, convenience, safety, and an environmentally friendly life. Relying on our manufacturing strength and know-how, we are focused on building an AIoT smart home ecosystem with technologies such as facial recognition, language recognition, big data, and IoT. We are dedicated to becoming a technology services company that creates the most value for society. We are fulfilling our corporate responsibility in areas such as employment, taxes, giving back to society, and globalization. We strongly believe, with you at our side, that we will create a beautiful new world together. Let's create the future together.
Well, thank you for watching this promotion material. And I hope that will give you a different aspect of the foxconn. Of course, the next few minutes, I will also share with you the new adventure, new journey of the foxconn transformation to the new business and also new technology. As shown in this slide, from the phase 1 to phase 3, resources integration phase to the reverse integrations phase, and it's part of the disruptive innovations. Then from the phase 4 and to phase 6, it is considered as the sustaining innovation, and from the phase 6 to phase 9, it considered as the efficient innovation. Without the paradigm shift, without transformation, the company may fail. That is why there's so many companies fail after 40, 50, even 60 years of the existence and lost their leadership. Well, the next few slides, I will share with you the foxconn digital transformation and new industrial. After retirement of our founder, Mr. Terry Gore, in June 2019, foxconn kicked off the digital transformation and the industrial initiative in 2020. foxconn 1.0 aims to optimize current situations by allocating functions among corporate and subsidiaries and to generate higher revenue and profit. Indeed, it is the continuation of our lean IE transformation. foxconn 2.0. We focus on digital transformation by improving customer experience with AI-based decision-making and operation effectiveness and efficiency. foxconn 3.0 employs our 3+3 growth strategy by investing resources in 3 new industrials or new businesses, including electric vehicles, digital health, and robotics. And the 3 core technology consist of artificial intelligence, semiconductor, and the next generation communication technology, 5G and 6G. Through the foxconn 1.0, 2.0, and 3.0 transformations, we strive for transformation from labor-intensive to knowledge-intensive and capital-intensive. Of course, you may see that in sequence. However, we also transform in parallel. The upskilling and the reskilling of the foxconn more than 1 million workforce are one of the key factors toward the success of foxconn transformation journey. And that's why I resume my old responsibility in talent cultivations after years of the responsibility in running the business. As shown in this slide, and we also created 5 corporate research centers under the Hon Hai Foxconn Research Institute, including the AI, semiconductor, next generation communication, cyber security, and quantum computing, were actually established last year to explore the potential technology that could be applied and commercialized within 5 to 7 years. That means our business group and business unit, they are focused on their research and development in the product currently in operation or the new product introductions. For those may not be immediately available for commercializations, word it, compile, and run it under the Corporate Research Institute. After the technology mature in 5 to 7 years, those projects will be delivered, transformed to the BG and BU to commercialization and the implementation and move it to available to the market. And currently, we already have more than 10 projects in process. With the strategy of openness, B2B strategy, and also Foxconn has established an electric vehicle platform, called it MIH, to integrate resources and various EV Chen leaders to reduce development time and the cost. Currently, MIH platform has more than 2,300 members. Foxconn also joint ventures and business with leading automobile companies, including the Geely Group, the largest automobile group in China, Stellantis Group, the number 4 group in the world, as shown in this slide. Foxconn joined a venture with industrial computing device maker ADLink for developing autonomous mobile robot called the Far Robot. Foxconn teamed with the gyro gear to produce gloves for people with Parkinson's disease. Foxconn is accelerating effort to develop our own semiconductor supply chain in China to build a new factory in Qingdao in addition to the Nanjing, Jinan, and Zhuhai. We also cooperate with the other leaders, try to build up our semiconductor capability, not only in packing, also in the fab. As I mentioned earlier, Foxconn is one of few companies has been awarded 2 Lighthouse Factory by World Economic Forum. The first one actually was awarded in 2019 to our factory operated by the Foxconn Industrial Internet Corporation in Longhua, Shenzhen. By installing the cloud-based platform, connecting machines, making machine availability and operation efficient more transparency. As shown in these pictures, layout manufacturing is established, and UPH is increased by 31%. Our real-time monitoring and prediction system reduces unexpected breakdowns by 60%. Automated testing using AI reduces misjudgment by 50%. Internet of Things enable nozzle status tracking, extend the lifespan of nozzles by 25 times. With experience of applying and receiving the World Economic Forum Lighthouse Factory, we have certified 10 new Lighthouse Factory internally last year. Our second lighthouse, awarded by WES, is located in Chengdu, Sichuan. It just awarded this year. Indeed, we are planning to certify another 10 lighthouse factory internally in 2021 and submit 1 or 2 of our certified lighthouse factory to World Economic Forum for certifications. Confronted with the fast-growing demand and the labor skill scarcity, Foxconn Chengdu adopted mixed reality, artificial intelligence, and the Internet of Things technology to increase labor efficiency by 200% and improve overall equipment effectiveness by 17%. AI-powered optical inspection was installed to decrease manual inspection by 92%. Predict maintenance, aggregating historical and sensor data of all. Equipment effectiveness increased by 70%. Internet of Things enable manufacturing quality management. Advanced quality the athletics decreased inventory by 25%, as shown in these pictures. And then the lighthouse factory is shown. And in the bottom of this slide, this picture shows you our engineering actually is using mobile phone with the application software to deal with operation issues. So you can also see our FA robot on the shop floor. So as I mentioned earlier, we have certified 10 lighthouse factory internally last year. This year, we will certify another 10. Gradually, we will continue to certify our own Lighthouse Houston, and we will accumulate our experience and also continue to create and apply the different tool. Then later, we may offer our service in the smart manufacturing system to our partner in supply chain in the other companies in China and in Asia and the United States, etc. Well, with experience of the foxconn manufacturing technology and reference of the World Economic Forum guideline and criteria of the lighthouse factories, Foxconn has developed the lighthouse readiness assessment system, including 3 building blocks, 9 pillars, and 18 dimensions. 3 building blocks covers system intelligence, smart technology application, and intelligent manufacturing and organization. Each building block includes 3 pillars. For example, system intelligence block covers production system, supply chain management, and product life cycle. Building block of the smart technology applications covers automation technology, interconnecting technology, and intelligent technology. Intelligent management and organization block divides into talent, organization and management, and culture. The next level of these structures covers 18 dimensions. For example, pillar of the cultures covers 2 dimensions: mindset, innovation, and development. The leader wisdom and the control dimensions. Pillar of the organization and the management covers collaboration of inside and outside of the company. And a smart strategy and management. We have established the Industrial Internet Promotion Office to promote Lighthouse project internally. And as I mentioned earlier, may offer our services to our supply chain partners and other companies later on. Well, that is a sad story. Dr. Yuan Longping, plant scientist who helped curb famine, died at 90, was arbitrary on the New York Times 2 weeks ago. Dr. Yuan's contribution of developing the high yield rice hybrids in the 1970s, saving countless lives in Asia and Africa. As shown in these pictures, Mr. Yuan in 2004 with Norman Borlaug, the Nobel Peace Laureate, who made the breakthroughs in wheat cultivations. Both used the hybridization technology to rice harvest. Hybridization actually plays a very critical role in evolution, genetics, and ecology to assist all livings on the plant to adapt and survive under the dynamic environment. Transformations in nature and in business follow the similar pattern. This is a quote from Mr. Thomas Siebers, who is a member of the American Academy of Arts and Sciences. He also is a billionaire and the founder and the CEO of the C3.ai, listed in the New York Times, the New York Stock Exchange. And he also the author of the Digital Transformation, Survived and Thrived in an Era of Mass Extinctions. Indeed, more than 50% of the Fortune 500 either acquired, merged, or bankrupt since year 2000. With the same concept, I propose a double helix transformation model with my personal experience in academic and industrial to help companies in transformations. Washington State Governor Inslee is the advocate of the lean transformation and has promoted and implemented lean management in government services. He continues former Governor Christine Gregorius' Executive Orders 1104 lean transformation since he took the office in 2013. As shown in the Governor Inslee's annual conference opening speech, digital transformation is embedded in the lean transformation. You could treat the lean transformation and the digital transformation as the two strengths of the double helix model. The key of the lean transformation is the mindset with the listen, learn, and lead qubit L approach. Digital transformation begins with the installation of ERP system interconnecting the various service functions by interfacing with users through the different type of applications. 16 of the 50 states in the United States has issued executive orders to promote lean transformations. As I mentioned earlier, last year I spent most of my time in the state of Wisconsin. Wisconsin also has executive orders issued by the former governor, Scott Walker, and continuing with the current governor, Tony Evers, although they belong to the different parties. But to work and provide a much better service with efficiency and effectiveness of the government service to the people. In order to acquire the new business, attract the new business, invest in the state of Wisconsin. That is the main reason they issue the executive order for the lean government or lean management in government service. And by combining the digital transformation, many of the people treated lean transformation and digital transformation as the two independent, separate transformation. Personally, I believe it is wrong concept. And my personal opinions, transformation provides a basis after we optimize all the process in our operations. Then just doing the information, IT technology to the digitalizations. Then unless you have optimal processes, once you connect all the devices with the sensors, we all heard the garbage in, garbage out. And that is the outcome going to be have if people ignore the importance of the lean transformation, and I would say the lean IE. In 2011, General Electric GE embarked upon an ambitious attempt to digitally transform its product and service offerings. The company created impressive digital capability, embedding sensors into many products, building a huge new software platform for the Internet of Things, and a transforming business model for its industrial offerings. GE also transforming internal processes like sales, supplier relationship, although some performance indicators, including the service margins, began to improve. However, investors did not seem to acknowledge its transformations. The company's stock price has languished for years, and the CEO then, Jeff Immett, who is a powerful advocate of the company's digital ambitions, ended up have to leave. GE currently, have the new CEO and the chairman, Larry Culp. Larry Culp, indeed, he is the former president and CEO of the Danaher, who is the first and very successful the transformer and practitioner of the Toyota production system. And he actually put the lean management and lean philosophy into the actions. And on the basis of the lean transformation in GE, digital transformation is integrated to use the data in analytics, countermeasures, and standard work, optimize operations and the infrastructures to drive culture of innovation. As shown in the second, the bottom of this slide. The lean transformation process cycle consists of the problem-solving report, value stream mapping, process and data flow analysis, action plan with digital countermeasures, digital standard work, and AI-based Kaizen. From this circle, digital integration integrate with the lean transformation process from the process and the data flow analysis till the AI-based Kaizen as shown in the diagram. So from the GE's philosophy and his business product, they combine the lean transformation and the digital transformation together. Although we are talking about industrial internet, although we talk about smart manufacturing, I would like to re-emphasize 3 different key points I would like to share with you today. First, have to be people-oriented. The second, have to continue to implement the philosophy and the mindset of the lean with the foundation of technology background from industrial engineering and the mechanical engineering. Then thirdly, no matter which model we use, with dynamic change and a challenge and the pressure from outside and inside, we need to have continuous improvement, the Kaizen, with the implementation for digitalizations. Our traditional Kaizen, continuous improvement, will be called the new name, called the digital Kaizen. And many of you may learn it, the disruptive innovation from the late Professor Clayton Christensen. And this is one of the famous model by him, the economic engine model. Disruptive model for the new market enablement. Then, sustaining innovation, try to improve the performance effectiveness, then efficient innovation. Just focus on the process improvement. Of course, during the efficient innovation, some resources may be released. Unless you can utilize those released resources, have the paradigm shift, looking for the new business opportunity, and have another round of the disrupt innovation. Otherwise, the company may die. So that is what I say. No matter the traditional Kaizen or digitized Kaizen, continuous improvement actually is the cornerstone of the innovation. Our founder, Terry Gou, used a very simple definition to define the innovation. He said that innovation indeed is to make a difference and it can be better. And Many of you may study different algorithms in the school, study different theory in the school. In Foxconn, continuous improvement, no matter traditional Kaizen or digital Kaizen, we have three basic elements. The first element have to be include and have some foundation of the theory and algorithm. The second, have to design an experiment to run the experiment and test it, the hypothesis. Then the third element is to run a simulation or have prototyping. Of course, the goal of the Kaizen, continuous improvement for innovation, is to reach or achieve the target with the performance original designed. Then after the several cycle, the approach could be standardized and promote to other areas and other business unit. And I would like to use a little bit longer video to demonstrate how we use the Kaizen approach by considering the theory, algorithm, experiment design, and simulation to solve one of the real manufacturing problem. It's a SMT processing problem.
Today, Grandpa will tell you a story about the honeybee.
When spring comes, flowers are in full bloom. The honeybee has to fly from buckets to gardens, back and forth in order to pollinate their crops. However, she has many problems. These problems bother her every day. Actually, our industrial engineers meet the same problems as the honeybee when they are dealing with patching by SMT in some electronics.
In producing electronics by SMT, the job is accomplished by a mid-speed machine and a general-purpose machine with a two-faced double-joint board having 1,036 patches. Before now, patching was done by a CPS process. The three key problems are 1. Feeder position optimization, 2. Number of feeders for each holder, and 3. Patch route optimization.
First, let us focus on the problem of pouch route optimization. In fact, the problem is about determining the honeybee's pollinating route, or about the patch route optimization with SMT, mid-speed machines, and general-purpose machines. They are both TSP, traveling salesman problems, and can be solved by some algorithms.
Algorithm TSP is the best solution for multiple perspectives. The problem is how to find the shortest route.
There are many cities. The one traveler starts from one city and returns to the city where he started, but he needs to go through all cities.
After analyzing and classifying parts of the baseboard according to their number and size of corresponding holder types and machine types from SMT, we set up an equation by means of an analog annealing algorithm to find out the shortest route.
Through simulation testing and the comparison between CPS optimization and TSP optimization, we found that the route optimized by TSP has no backtracking over a route already covered, thus providing the optimal route.
It really saves me a lot of efforts for making honey with this method, but how can I find out the shortest route for flying back and forth with a limited capacity bucket?
Let's go find out the answer. To find an optimal route, we also consider two key factors. 1. optimal feeder position, and 2, the feed-in quantity of the holder. Also to the honeybee pollinating, what we have done is to find the shortest route, with the wanted flowers being of a common variety in a centralized area with limited capacities. We set an objective equation through the mathematics model and used genetic algorithms to solve it. Let us now turn to genetic algorithms. Genetic algorithms, abbreviated as GA, which are a kind of algorithms that are quite suited to the current situation, can optimize the process of searching for probability. They are formed by simulating the hereditary and the evolutionary course of living beings in a natural environment. A GA regards the possible solution in the question area as one individual or chromosome of the colony and encodes each individual with a symbol string. We encoded the CPS procedure to follow the colony code of the primitive gene operated repeatedly on the colony according to genetics, selections, crossbreedings, and mutation, which selects the superior and eliminates the inferior, thus optimizing the colony continuously until we reach a final condition. Then we calculated the solution with the GA, allowing us to find the best feeder position, feed-in quantity of the holder, and the optimal path route. After implementing the solution successfully, bottleneck time for the mid-speed machine and general purpose machine dropped from 28.2 seconds to 24.1 seconds.
Oh, using GA for the same colored flowers in a centralized area, I can find a better route even with limited container capacity?
Continue studying.
At this moment, the bottleneck is transferred to the printing machine by the flow process analysis. The printing machine is the first step in SMT procedure.
Before now, problems with the printing machine lay in 1. Printing procedure work takes a long time. 2. Channeling into the track also takes a long time and may cause the patch transportation time to last too long. To deal with a long channeling time, we added a buffer that reduces the transportation time effectively when the patch comes to the printing machine. For the long printing procedure work time, we adjusted corresponding parameters and verified the mutual influence between printing procedure parameters and baseboard quality using DOE experiment tactics. In the actual operation, we used DOE and found a little mutual influence, so we can choose a reasonable quality level to revise the parameters. In this way, the takt time of the printing workstation has now dropped from 27.9 seconds to 23.3 seconds.
Let me have some honey after a hard day's work of learning so much IE knowledge. Yucky, it doesn't taste good.
What's the matter?
Oh, it's yesterday's honey. Now that I have learned DOE testing techniques, I can choose the optimal parameter and brew honey after considering buckets ventilation, temperature control time of honey brewing, and classification of honey.
Look how happy she works. By means of IE techniques, she optimized the pollinating and the honeying route and brewed the best honey. See how important it is to be an IE knowledgeable honeybee?
Grandpa, when I grow up, I will be a smart and a hardworking honeybee with IE knowledge.
Well, that's the brief videos we developed based on our cases study in our production line. We have created hundreds of these similar type of the videos. Help us to cultivate our talent. And let's show this slide. And we design and compile series courses according to the Intelligent Manufacturing Technology developer framework. To begin with the safe, health, and efficient shop floor operation. A set of the shop floor management tools, such as 5S, visual management, Kaizen, top 10 ways, and 7 methods of IE, 7 methods of quality control, etc., are designed to train our intelligent manufacturing system engineering with solid fundamental knowledge. IE and automation department are the leaders in this stage. I call it lean production stage. Of course, Six Sigma, ECRS, value stream analysis, and other basic lean knowledge are needed. And this phase, I call the digitalization stage, should be led by IE and IT department. Then IE and the 4T department. 4T means operation technology OT, platform technology PT, digital technology DT, and analytic technology AT. So IE and the 4T are responsible to lead the intelligentization stage. Of course, natural language process, data mining, machine vision, machine learning, etc. are core courses are needed. And as I mentioned earlier, through the NSF Big 10 ideas for the future work environment, and certification is one of the solutions to provide more qualified engineering. So we also set it up a certification system, and with the roof of the operation management, with the foundation of the corporate cultures. A total of the 28 certification program has been developed. 8 programs to certify engineering in IE, Six Sigma, and lean supply chain management areas. 9 programs are designed to certify engineering in data acquisition, data transmission, data control. 6 programs are designed to certify engineering in ERP, EDI, IES, SFC, and WMS to work on digitization project. Another 5 programs, such as data processing, big data project management, big data visualization, industrial artificial intelligence, and big data structures, are offered to certify engineers in intelligentizations. So those are the certification programs we are working now, and we are now all being offered internally. We also provide those kind of surveys outside the Foxconn. And we also team up with a different professional society in China and work with them to certify their applicants in terms of a different phase of smart or intelligent manufacturing. And we adopt OMO model in our training and development. That's me, online merge offline. It is a new delivery model we use. As shown in this slide, an app called 复学宝典, or called the foxconn-edu, is developed and has been certified by the Shenzhen city. Indeed, it is the main learning channel last year due to the pandemic. Users or learners could get access to this app with various types of devices at any time and any place. Individual learners' learning plan has also complied with his or her career development plan. A total of 18,508 courses with 3,652 courseware are loaded in this app. This platform probably is the most abundant occupational or vocational training platform in terms of content, This platform is also targeted to be the smart career housekeeper for individuals. You could use this platform for job matchings, real-time reminders, learning roadmap, career roadmap, customized learning plan for a company or enterprise. The platform could customize into a dedicated platform. Also customize curriculum for their company's employees. Then we also provide a real-time training and learning dashboard and smart decision support and accurate predictions. And this is the real-time dashboard. We have more than 1.9 million registered learners now. As shown in this slide, the training and the development department could get access to this real-time dashboard with collection and analysis of the learning and career interest. Platform could provide customized, accurate, and efficient learning and career development recommendations. Well, as shown in this slide, IE bridge the human and technology. I also promote the IE as the profession of the people oriented with care and love since I started my career 40-some years ago. This will conclude my today's talk. Again, thank you for the invitation. Everybody have a good day. Be safe, be peace, and healthy. Bye-bye.
Thank you, and take care. Bye-bye.
Bye-bye.